Hello scholars, welcome. My name is Mr. Hinkle and today we are getting into the rock cycle, which is an amazing feature of Earth. The rock cycle describes the birth, the formation of rocks, how they transform from one type of rock to another and the processes that allow those transformations to occur. And then it shows the ultimate fate of rocks, the recycling, so that the cycle can start all over again. It is a nonlinear process that expresses how geology is all around us. It is constant, it is dynamic, and it is part of our Earth. So, let's get into it. Today we will define what a rock is, introduce the rock cycle a little bit more. We'll talk about the processes driving the rock cycle all along the way. We will discuss the three types of rocks and how they form, and then summarize the rock cycle and discuss how it changes through time. So, let's get in. What is a rock? Here's a rock, zoomed up really close. This rock is granite. A rock is made of minerals. Minerals are made of elements that form compounds through chemical bonds that create the raw materials of Earth stuff. If you'll remember, a mineral is an inorganic solid with a definite chemical composition and a crystalline structure that is naturally occurring. Our big five for the definitions of a mineral. So, minerals like quartz, feldspar, biotite grow together, they aggregate to form a rock. Rocks are ubiquitous on Earth. Earth is a rock in various forms, but the outer shell, the eggshell, if you will, of our Earth is composed primarily of rock. The theory of plate tectonics states that the surface of the Earth is covered by large, rigid, lithospheric plates. This lithosphere comes in two types: oceanic crust, continental crust, and each of these is composed of a primary rock type, granite and basalt. Now, it's much more complex than that on our Earth, but that's a good place to start, and that is where we launch into. So, a rock can be one mineral, it can be many minerals, it can be mineraloids, which are mineral-like substances, for instance, volcanic glass that has no crystalline structure. Rocks can include individual minerals, inorganic non-mineral solids, said that, pieces of broken from other rocks. Rocks can have fossils. Awesome. Geologic materials may be inorganic, but they can also be organic. Thus, our big three fossil fuels, coal, oil, and natural gas, that form in rocks. Awesome. So, rocks are wildly important. They're all around us. We live on this Earth. It is a big rock, and for that reason, if not for any other, besides how cool they are, we could talk about it. So, the rock cycle describes the formation, the transformation, the evolution, and the fate of rocks in our Earth. There are three types: igneous, metamorphic, and sedimentary. And this is the bulk of what we're discussing. How do we get from one rock type to another in this dynamic system of the geosphere? If we think about the Earth as a system, there are four main spheres to our planet Earth. The hydrosphere, that's water. The atmosphere, that's air. The biosphere, that's life. And the geosphere, that is rock. This is what we're talking about today: the recycling, transformation of Earth materials. So why does this happen? Why do we have rocks changing type on Earth? Well, let's go to one of my favorite images to reproduce. Earth has an internal structure that is layered by density. Core mantle crust. And 4.5 billion years ago, it was one big homogeneous ball. It was really hot. And as it started to cool, the Earth stratified by density. Dense material to the center, lighter material to the surface, and it started to cool. But the inside of the Earth is still really hot. And that heat that exists in the core moves through the mantle, and it drives movement of large lithospheric plates on the surface of the Earth, and this is plate tectonics, the unifying theory of geology, which helps us understand why we have mountains, earthquakes, oceans, sedimentary basins, and every other feature that we see on this Earth. It makes it all click and make sense. So, plate tectonics and the movement of heat, wildly important for driving the rock cycle. The other part of it, the physical and chemical breakdown of rocks on the surface as driven through the processes of wind, water, air, ice at the surface. This is thank you to the hydrologic cycle. In its most basic form, we have evaporation from the ocean, condensation in the air, precipitation down to land, and runoff back down to the ocean. This is much more complex, but here we go, the basic hydrologic cycle. So these two things together, Earth's internal heat, plate tectonics, hydrologic cycle, the movement of water on Earth, give us the mechanisms that are driving our rock cycle. Great. So we've got a broad overview of our three types of rocks: igneous, sedimentary, metamorphic. And how do we know what rock is what? Well, we look at it, we observe the physical characteristics on that rock, and based on those, a geologist or a trained individual like yourself can identify the methods of formation. And way zoomed out, it's igneous, crystallized from molten material. Sediments are deposits of other rocks, sedimentary rocks, and metamorphic rocks are rocks that have changed their form. Here is our broad overview. Let's dive in a little bit deeper. So our story starts at magma or lava. Magma is molten material, rock that has melted underneath the surface of the Earth. There are certain conditions that generate magma. We'll save that for our discussion on igneous processes. But for this discussion, magma exists underneath the surface of the Earth. Now, when magma erupts through a volcano onto the surface of the Earth, it becomes lava. So this is a technical definition. Magma is under the Earth, the surface of the Earth. Lava is on the surface of the Earth, but they are both molten material, Earth materials that are molten or melted. Igneous rocks form from the crystallization of molten material. So, what do we have? We have substance, magma or lava. Now we have a process, crystallization. You could say this is from cooling when it becomes solid. The process of crystallization is going to give us igneous rock. So how do we classify an igneous rock? By the way that it forms. How does an igneous rock form? Through crystallization of magma underneath the surface or lava on top of the surface, giving us a variety of different names of rocks, again, based on how they formed. Under the surface, on the surface, in an explosive volcano, in a diffusive volcano. More on that to come. But we have two main types of igneous rocks: intrusive which are rocks that form inside of the earth from magma, and extrusive, which are rocks that form above the surface of the earth from volcanoes. Now, intrusive rocks have large crystals because they cool slowly. Extrusive rocks have small crystals. This is one of the ways, there are lots. But when we're identifying rocks, we look at the rocks and we say, how does this rock look? Does it look like a bunch of puzzle piece interlocking crystals that are relatively large? Intrusive, igneous rock. Great, let's keep going. So we're back to process now. The process of weathering. Weathering is the breakdown of rocks. We have physical weathering, where it is the actual breaking of rocks from larger pieces into smaller pieces. And we have chemical weathering, which is the dissolution of rocks into water. Both are important for taking big mountains like we see here, grinding them up, breaking them down into smaller pieces, which eventually will end up in a river. Rivers like to go to the oceans. So weathering is the physical and chemical breakdown of rocks. Weathering leads to erosion. So when the rocks are broken down, they are then picked up by some agent, by a river, most commonly, by a glacier, by wind. And they are transported. So erosion is a natural process, and it gets a bad rap because people who live in places that are eroding don't really like it. Unfortunately, when something becomes a nuisance to humans, we villainize it in such a way, like plants that we don't like, we call them weeds, and insects that we don't like, we call them pests. But they're just plants, they're just insects. Erosion is just a natural geologic process. Erosion helps to carve landscapes. So it goes like this. We've got a big block of rock, big mountains. Weathering breaks up the rocks. Erosion transports the rocks. And then when these particles that are being transported settle out, they are deposited. So the process, or we could say the processes, are weathering, erosion, and deposition that gives us sediments. So, our next feature in the rock cycle is going to be sediments. Sediments are small pieces of other rocks. They were once part of large deposits, but those large deposits have been weathered, eroded, transported, deposited. And when they end up somewhere new, they're deposited as sediments, like the unconsolidated material in Tamales Bay that is ultimately making its way to the ocean. A little outside of our scope, but when sediments are created, they end up in sedimentary basins where they stack up over time. Now, these sediments become sedimentary rock. How does that happen? Well, very good, through a process. Sediments to sedimentary rock. Give me some time here while I work on my squat. So, you and 30 of your friends are having a good time, enjoying each other's company, and somebody gets the wild idea to make a 30-person dog pile like when we were kids and we used to stack all of our bodies on top of each other. Well, you know, probably from experience, that you don't want to be the person on the bottom because you feel the weight of all the people above you. If there's just one person, not a lot of weight. If there's 30 people, a lot of weight. So when sediments accumulate in layers in a basin, the more layers that are accumulated, in this case we'll replace people with sedimentary layers. One layer provides a little bit of weight, 30 layers provides a lot of weight. So that overlying weight compacts the underlying layers. This is one of the process. Compaction. As the sedimentary layers are being compacted, water is being squeezed out of some of the pore space, you have chemical reactions that actually glue the individual particles or the sediments together through the process of cementation. And when you bring these two things together, we have what is called lithification. So sediments lithify into sedimentary rock. This is our second kind of rock in the rock cycle. Okay, let's keep going. Process. So I mentioned earlier that the center of the earth is hot, and there's actually a gradient from the surface to the center where it gets warmer. Temperature at the surface, and it gets hotter in the lithosphere. There's a temperature gradient change, rate of change, that goes from the lower mantle to the outer core, and then hot, 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 all the way up to about 7,000 degrees Kelvin in the center of the earth. Wow, that's hot. This is why nobody's actually ever been to the center of the earth. Too hot. We would vaporize immediately. Since it gets hotter closer to the center of the earth, as rocks are buried through processes of mountain building, continental collisions at convergent plate tectonic boundaries, these rocks are subject to heat and pressure. Heating and pressure are processes that end up changing the form of the rock. Meta means to change. Morph is the way that it looks or form. So metamorphic rock are rocks that have had their form changed. Identified through the texture, the composition, if we see evidence of foliations, migration of minerals of similar type, distinct banding, folding, as you develop your geologist's eye, certain rocks will jump out at you as the only way that could have formed is if it was existing previously and then it changed from one form to another. So metamorphic rocks form under heat and pressure from a rock known as a protolith. Now, protolith go under changes, occurs deep within Earth's crust. Common rocks are schist, gneiss, and slate, marble. These are all building materials. Metamorphic rocks are strong, and they've been used for raw materials for a very long time. Let's finish the cycle. Put a chocolate bar outside on the concrete. What happens? It melts. It gets all sticky. Well, put metamorphic rock deep enough into the earth. What's going to happen? Oh, it's going to melt. I don't know if it gets sticky or not, but it will turn into molten material, given the right conditions. It's got to be between 600 and 1300 degrees Celsius, and the right conditions of heat and pressure have to happen for melting to occur. So that's pretty. We have this nice circular path from one to the other. It looks very linear at this point, but let's not be fooled. This is a non-linear path. And it goes a little something like this. We'll use purple for extra pathways. We can have metamorphic rocks that are exposed at the surface, undergo the processes of weathering, erosion, and deposition, and then they become what? Sediments. We could have sedimentary rocks that are exposed at the surface and under weathering, erosion, and deposition become sediments. We could have igneous rocks, skip all of these steps, and with heat and pressure become a metamorphic rock. We could have igneous rocks melt, sedimentary rocks can melt. Metamorphic rocks can actually undergo increased metamorphism and become a higher grade metamorphic rock. That's interesting. And I believe we have covered most of our pathways. So, the rock cycle is a fundamental geologic phenomenon that shows the movement, the transformation, and the recycling of rocks on Earth. And when we zoom out and we look at this, we can see really how dynamic our Earth is and how variable, where some of these processes, erosion, we can literally go to the river after a rainstorm and see it happening. And some of them take a long time, millions of years to bury, to become heat, to change their textures and their composition of their original rocks. Along with plate tectonics, understanding the rock cycle is essential for understanding how our Earth works, how our Earth forms, and then explaining why we have that peak that's so big, Mount Everest. How does it keep getting taller every year? Fold and thrust belts through a continental collision. Why we have sedimentary basins in the oceans and on land. Why there is land, why there is oceans to begin with. Why do we have land? Why do we have oceans? We can use the rock cycle and our modern theory of plate tectonics to explain it. So, in conclusion, we've got three main rock types: igneous, sedimentary, and metamorphic. But the story is much more interesting than that. It's actually a fantastical story of the movement, the transformation, and the recycling of rocks in a nonlinear process through deep time or geologic time. And we use this story for understanding geologic processes on the surf today and how the Earth was formed. Thank you so much. This is the rock cycle.